Da-da-da. Well, there we go. Hey, it is 2 hours UTC, and it's time again for Astronomy Daily Live. So welcome everybody. Come on in, join the ever-growing crowd that gathers together here pretty much every single day for about an hour or so. It usually goes over because, the science of astronomy is huge and extremely exciting. And so, I get carried away every single day. Just I'm thinking about things astronomical, and I'm talking about it, and I'm looking at things, and I'm thinking about things, and then I look up at the clock, and it's like, way past an hour, and so yeah. But that's how it is when you're having fun. Time flies. So Todderbert's in the chat. Hey ho there, nice to see you in chat, and both in the chat and on panel is Tom. Hey there, Tom.
Hey, happy day, everybody.
Yeah, pretty happy day. And also on the panel is Bobby. Hey, Bobby.
Hey, yeah.
I think Bobby's put his quarter speed on, so you're just gonna have to forgive him because things are going to be moving a little slowly or so.
Are those sounds of joy, Bobby?
Thunderbird, what's in your radio giveaway?
Yeah, he told me about that a while ago, and no, I did not enter your giveaway at all. But yeah, if you want to remind us what that was all about, that'd be great. I in general don't enter any kind of contests or anything. I'm not really a competitor in any sense at all, and even if it isn't a competition, sort of like, well, throwing your hat into the bin and getting randomly chosen. Yeah.
SB and $190 value.
Yeah, cool. Very, very cool. Yeah, nice. I like to see lots of others.
AM, FM, or shortwave, or what?
It's probably a whole bunch. At that price, you can probably buy the farm. Probably. But yeah, I like to see folks winning at those kinds of things. My joy comes a lot from seeing other people's joy, and that's all I need. So yeah, when somebody wins something like that, be it a drawing or a contest or something, I always like to watch the winners because they're usually ecstatic, and I like that. So yeah, well, 89. That's a pretty good. That's a pretty good count. That's pretty nice.
I kind of like it too. Airband, shortwave, AM, FM, weather band, and if you use sideband for listening to the hams and stuff.
Yeah, cool. Nice. Yeah, so well, somebody's going to win that, and I think that is absolutely fantastic. So yeah, if you're interested in that, and even if you're not, get over to Todderbert's YouTube channel. He reviews all kinds of radios, and yeah, usually pretty interesting ones, and very, very cool. And it looks like we have another week to throw our names into the hat. So yeah. But like I say, even if you're not interested in drawings or contests or this kind of radio, get over there anyway, because he's got a pretty great YouTube channel. And speaking of great YouTube channels, this one is called Astronomy Daily Live. And so what we're going to do for the next little bit here is sort of think and talk all things astronomical. Of course, we get on to tangents. That is perfectly acceptable, because that is science. That is science. Because you never quite know where things are going to, sort of lead you. So yeah.
And it doesn't hurt to subscribe to Tottenberg right now, like I just did.
Yeah, go over and subscribe over there for sure. He puts out, wow, and I've been noticing, and honest, right? I mean, I definitely do not watch each and every one, but I do notice when there's a new one, and I think he's putting out, I don't know, 1, 2, 3, 4 of them a week or so. It seems to be a lot. Maybe I'm not paying incredibly close attention, but yeah. So he's putting them out pretty well. A video every day. Oh wow. Okay. Cool. So yeah, I haven't quite been paying that kind of attention, I guess. I thought it was a few times a week, but every single day. That's for any kind of production at all. That is rough. See, these live streams require absolutely no production whatsoever. The only thing I have to do is show up, and that's it. So whatever they are, and yeah, I don't really make any plans. Not necessarily. Sometimes I'll have some kind of a topic. Always have a topic or 2 or 3 or 10 in right here in my back pocket. But for sure, if folks on the chat, folks on the panel have anything at all to bring up, this is like a virtual porch, right? So we're all sitting around, relaxing, right? Have our consumables of choice. Cheers. And just sort of, chewing the fat, but keeping it pretty much in the groove of astronomy, more or less. So yeah. So let's see. I think I just watched Tony Darnell's Deep Astronomy coffee talk. I forget exactly what it's called, but and he talked a little bit more about the Hubble Space Telescope. Actually, Christian Reddy's video from maybe a week ago or so now, over on Launchpad Astronomy. He really did an excellent job at sort of explaining all the different parts and what they did and all that kind of stuff. So definitely check out Launchpad Astronomy on YouTube also. But for sure, check out Tony Darnell's Deep Astronomy. So there's all these astronomy things, right? Funny.
I'm
Uh,
not sure if you was aware, but the ISS it's scheduled to send out some slow scan television images from like their Russian transponder and stuff,
oh,
starting
cool.
at 1000 UTC on Saturday,
Nice, nice. Are you going to
which
try?
is usually 5 o'clock local here,
Yeah. Are
and to
you
about like three a.m. local.
are you going to be in a position to grab any of those? Are they going to be passing over you?
Well, what I was planning on doing is bring my whip out and then use this RTL SDR dongle to try to capture some of the images.
Nice. So you think you'll be able to do that from
I
your
did
location?
tell Jills to use the Obertron SDR short method in Windows and the gpredict GQRX method for Linux-based computers.
Cool. Well, hope that goes well. They usually send down some you know sort of tacky pictures, sort of PR things, which um,
Okay, Counterbird is 145.800 using narrowband FM. And sometimes you gotta watch yourself because it ships. And as it ships, you gotta keep on tuning. And the more that you stay on on that frequency, where's it at and stuff, the better you should have it. So that's why I'm suggesting that if you use an SDR on, like, I'm not sure if you're a Windows person or a Linux person, but like I said, on Windows there's the Orbitron and SDR short method, and for Linux there's a GQRX gpredict method.
cool. All right. Well, I hope those passes go well, and that all gets sent down to those who are receiving. So what I'm going to do is I'm going to move to yesterday. I don't remember what exactly why exactly I was talking about the Mars
Now
opportunity.
you focus on the images of the day by NASA.
Yeah, was that? I don't remember exactly why, but yeah, we were talking about the rovers and I was
Just out of my curiosity, what type of equipment do you use and stuff?
yeah. Let us know.
Hey, Cosmic, before you move on,
Yeah.
I did watch the Deep Astronomy today, and I thought Carol Christian, I think that's her name, she did a nice job explaining the pointing system on Hubble. And like she went over the gyros and the reaction wheels and something else called the star pointers or star finders or something like that. I thought it was a pretty good show today.
Yeah. Have you seen Christian Reddy's video about that yet?
No, I'll have to take a look at that.
You will definitely, because it dwarfs what Carol was talking about. Carol, explained things, but Christian really did a bang up job going into detail and making all those systems very understandable. So
Okay, cool.
so yeah, check him out. But yeah, I thought that was great, and it sort of seems interesting that at least the last I heard was that with the gyro that failed, they did what every good engineer should always think of and always do, right? And that is turn it off and then turn it back on. Just cycle power, right? Cycle power I mean, I've got so many years of experience with this, right? It's like turn it off, turn it on, and it works.
Even us bad engineers do that.
Well, good engineers should do that first, right? Always, 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 always. So apparently that's what they did, right? They turned it off, they turned it back on, and it. I guess at least the last I heard was that it seems to be operating okay now. Is that the word? Um, Anything different?
That's what I heard too. Is that it's now functioning normally, and they're going to figure out what to do to get it back to science.
See that that is maddening, right? Because it's like, um, it's like, okay, well, why did it fail, right? Uh,
Sticky electrons, Cosmic.
Sticky electrons. Okay,
Yeah. Instead of push them through somehow.
I can buy that.
So,
Yeah.
so what they did, they just rebooted that gyro and everything's fine?
Apparently so. Yeah, yeah. Which like I say, to me is sort of maddening, right? Because it's like, no, 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 no. But I mean, also in my experience, right? I mean, decades of experience now, right? It's like that, whatever that does, right? Whatever that does, um, it resets,
I guess the engineers
revitalizes.
will be like, I'll be a son of a brisket.
Yeah, yeah, because, and actually they were talking about this on Tony's live stream, and that is, the engineers want to get in there and try to figure out, why did it fail, you know, and try to push it, right? Try to stress it in order to make it fail again. And that's sort of my thing too. It's like, that's what testing is all about, right? Is you try to break it, right? And if you can't, it's like, okay, we're good. But, like they said, do you want to break this gyro that is, like one of what, 3 left that are working? No, you don't. So you don't want to try to break it because you really, really, really need it. So if it works, right? If it works, just leave it alone. Leave it alone because the people are. Yeah, I mean, we've lost. What I don't know how many. I don't know how many days it was down. I want to say something like maybe 3 weeks or so. I'm not exactly sure. Let's just assume 21 days. Got the handy dandy calculator here. 21 days times 24 hours. 504 hours. So let's see, we can multiply that by 60 minutes. So 30,000 minutes has been lost. That's over the lifetime of the HST. It's not a big deal, but 30,000 minutes. That's a lot of time. That's a lot of time. So yeah, if the thing seems to be
Now,
working,
are you a fan of South Park?
I'm not really a fan. I mean, I know about it.
Because there's that episode when the internet was just fine and dandy, you could do whatever you want, do your research and stuff, and then when you get up the next day, it's like, boom, you're not gonna get anything, and it was like that for days and stuff, and then on Sunday they rebooted the main source, and everything was all right. So yeah, those insurance was like, oh, be a son of a gun.
No, that's it's absolutely amazing, and when that happens, right? What I think, what goes through my warped head, right, is that I wish that I had that kind of reset button, that I could either turn myself off, turn myself back on,
Yeah.
and everything would sort of be working again. I think that would be great. I mean, we don't have those. I wish that we did, because it seems to work.
After that episode, even the news people can't get the news because they didn't have an internet.
Yeah, well, not having the internet sounds like my situation too. so yeah.
Sounds like Jesus is coming. Jesus is coming.
So yeah, another thing, and actually this is I'm gonna sort of move towards what I want to talk about tonight, and that is Mars. Yesterday, like I said, we were talking about the rovers and how I think they're sort of planned missions were like 90 days, and Opportunity has lasted for 14 years, over 5,000 sols, Martian days, which is absolutely amazing, right? And one of the things that I had mentioned is just the tons and tons and tons of data. Excuse me, that is there, right? And so what I wanted to do was I wanted to go over and look at some of this data and see if there's anything kind of interesting to look at. And I did. But before I do that, I just wanted to show you this one site. There's a site that I've been using in my astrometry and photometry work, trying to characterize this telescope here behind me. I've been using this site called Astrometry.net. I'm going to share my screen here. I'm going to show you. Let's see. Let's go over there. We can do it like this.
I see you pulled that wallpaper from yesterday's live stream.
Yes, I did. Look at that. There it is. Just like I promised. Yep. You betcha. You betcha. So astrometry.net, and actually the site is it's nova.astrometry.net. You go to this site, you get this. Okay, it says down here, connecting for a while, right? And you got these spinny images here, and this thing just spins and spins and spins, right? So then, if I try to upload, it does this. And it's like, uh-oh. So I'm sort of interpreting this as something has happened to this website. And that sort of sucks because, like I said, I've been using this site to actually get my plate solutions for my for the.
Tell me that's your ISP doing it.
I don't think so. I don't think so. The fact that these images aren't loading tells me that they're having some kind of trouble. Now, I guess I haven't really dove into this too hard, and I'm not really going to. Okay, well, those images came up. Okay. Those images came up. So, yeah, I'm not quite sure. I'm not quite sure what's going on here. But anyway, just sort of getting it out there that I am.
I would like contact like the webmaster or something like that, and maybe they'll find out what is happening.
Yeah, I sort of, figure that
But
if
if they say it's the ISP doing it, well, I don't know what to do. Might have changed DNSs and stuff.
yeah, I figure they're probably on it, but I'm just sort of whining and complaining here a little bit because I'm trying to get some work done, and at the moment I'm sort of stuck. I'm going to have to probably find alternatives. Which is okay, but it's like this was working so well. Anyway, I'm just whining and complaining there a little bit. So I went over to the planetary data system machines, and let's let's go all the way back. Because I can find this again, pds.nasa.gov. So this is sort of a repository for all of the data that has ever been gotten by any of the spacecraft, starting, with the first ones all the way to the latest ones. In fact, they're releasing new data sets all the time. So yeah, here's a bunch of different ones, right? The Odyssey spacecraft, which is I think that's a spacecraft looking at the sun, if I remember right. Here's actually, I guess, yeah, the MERs, those are Spirit and Opportunity, I guess. So yeah, they just put out another release on September 28th, which sort of a surprising thing. I didn't think there was.
It's been like a good while since there were any of those releases and stuff.
Yeah. Well, they release chunks of data all the time. So yeah, here's the Lunar Reconnaissance orbiter going around the moon. Here's one around Mars. Here's another Mars. Here's Juno. Came out last July. So yeah, they release a little bit at a time as they get it. But anyway, so what I did is, what did I do? I think I went over to data search. Yeah, okay, so then we can choose a mission here. And like I said, the rovers on the ground are called the Mars Exploration Rover, MER. MER1 is, I believe, Opportunity, and MER2 is Spirit. I'm pretty sure. So I was just sort of looking around. It's like, okay, I'm going to go here, which is what I did. And let's see, where did I go from here? I guess I went here. Yeah. The geosciences node. Yeah. Okay. And so here's just a bunch of data from these two rovers. And so, I started looking down the list here, and there's, some spectra, and radiance measurement, images, blah, 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 blah. But then I saw this one, atmospheric opacity. So that is measuring, you know, sort of how hazy the atmosphere is as these spacecraft look out. And so I sort of thought, well, that might be interesting. Let's see what kind of format it is. So this is sort of diving into the planetary data system, into sort of the guts of the whole thing. And so you once you move off of this nice user-friendly kind of a thing, you start getting into basically like a file system. So you can see that there's directories here, and one of them is called data. So it's probably where all the data is, probably. And well, I guess there it is. There, I'm just sort of looking at the suffixes here, and let's see, LBL maybe is some kind of label, and then a TAB maybe some kind of table, right? So let's just look at these tables, and then I'm looking here too, seeing, okay, what's this all about? This
open
is
those types of formats.
What's that?
I'm wondering how you open those formats.
Well, you just sort of have to experiment sometimes. These labels are usually just text files. So, and in this case it is. And so what this is just sort of a description of the data. You know, what this data means, right? This is the meta data. And as you can see here, it's for Mars Exploration Rover 1. So that's Opportunity. There's a filter name here, PanCam L8, 440 nanometers. So that is looking towards the ultraviolet, right? I mean, it's still sort of in the visible. 440 nanometers is a nice violet color. Instrument ID. So I guess in this case it's the left PanCam, and here's the start time, 2004, January 26th, and the stop time is March 29th, 2018. So this is over 14 years worth of data. So that's pretty cool. So then it just sort of each sort of chunk here describes each column, right? So there's a column 1, column 2, column 3, column 4, 5, 6, 7, and 8. So there's 8 columns, and let's just sort of see here what this is. Product ID of some sort. Oh, here we go. So solar longitude, solar distance, local time, okay, air mass, solar flux. Oh, here we go. Atmospheric opacity. So that's an interesting number. And then there's actually the error in that measurement also. So that's pretty cool. Okay, so this looks like pretty interesting data. Let's see if we can actually look at it. It's just a simple text file. Very cool. So yeah, so here's the product ID. Here's the solar longitude. Is that what that was? Distance from the sun, in the astronomical units. Here's the Sol number. So this is the Mars day number, and wow, it starts at Mars day 1, and let's go all the way to the end here. Goes all the way to day number 5039, which is, I think, the last bit of data that we will ever get from that guy. So pretty cool. And it looks like they did, sometimes several measurements per day, not really evenly spaced, right? I mean, I'm sort of looking here, 5.41, 5.42, 5.51. So yeah, they're all sort of clumped together here a little bit, but that's okay. That's all right. No worries about that. They, I guess they have to make these measurements when they can. So yeah, they just take a whole bunch of them, and off they go. And let's see, here is the measurement of the opacity. It's called tau. And so, yeah, we'd have to go in and see exactly what these numbers actually mean or represent or anything. But yeah, I think suffice it to say that it can probably go from 0 to a pretty large number. So what I did, I've actually already grabbed this data, and what I'm going to do is, well, let's just move over to the screen, and I'll make it sort of big so we can see the whole thing here. So I took this set, which is opportunity at 440 nanometers, and just created a text file. I think I called it opacity 440, like that. So this is the same, let's see, should be the same, 906,883, 906,883, yeah, okay. So I think the first thing to actually do is just look at the opacity as a function of date, right, of Sol. So let's do that. Let's go into our favorite little plotting program. And as you can see by the file, every column is separated by a comma, right? It's sort of also separated by a space, but I have to specify one or another. So I'm going to do commas. So set data file separator to a comma. And then let's just plot the whole thing. So here's column 1, 2, 3, so 4, 5, 6, and 7. So 4 and 7. So column 4 is the Sol date. So I'll put that on the x-axis, and I'll put the opacity on the y-axis. So here we go, plot. And let's just see what it looks like. What did I call it? Opacity 440 using, I say 4 and 7. 1, 2, 3, yeah, 4 and 7. We'll just do it with lines. Line width 1, line color black. Let's see what this looks like. I'll make it a little big here. Make it very big. You can see it. So here's the Sol on the x-axis, and here's the opacity. So the larger the opacity, the dustier, or the more more hard to see through it is. So this is kind of interesting. On the x-axis, here's the... Whoa, I'm hearing big echo. Well, maybe I'm not now. Anyway, okay, so yeah, I'm seeing definitely like a periodicity here, right? Where there's these peaks, and then it happens again and again and again and again and again. So, that's sort of an interesting thing.
You know, cosmic? Then,
yeah.
Cosmic.
Yo.
Yeah, I got disconnected.
Oh, you did?
Yeah.
That's no fun.
The resolver botched.
Well, I'm glad you're back. I'm glad you're back. Okay, let's see here. So, yeah, you know, definitely a periodicity here. There's also this big peak here. Means that you know, the opacity went very, very high here. I'm sort of wondering if that was like a dust storm or something. Let's see, that was around Sol. I'm looking down here. That was around maybe Sol 1250. So let's, I can make a note of that, and we can try to find out maybe if there was a dust storm during that time. But there's also all these other interesting little peaks. Kind of neat, where you know, the atmosphere just got a little bit more opaque for a short amount of time, and then, you know, less opaque, right? And then whammo. So kind of neat. I'm sort of wondering if these are like annual things. I guess it would be on a Martian year scale. So yeah, let's find out. I'm just gonna do what I call like eyeball science.
So what are we looking at now?
Well, this is measurements of the opacity of the atmosphere of Mars as seen by one of the rovers, the Opportunity rover, over the course of its entire mission, right? So this is over 5,000 sols, which is, you know, roughly 5,000 Earth days. Something like 14 years. So I'm just going to do sort of an eyeball here, and I'm going to say that that's probably about the middle of that. I'm just sort of doing a little bit of a fit here. So let's see, that says 549. So let's write down 549. I'm going to create a new file here, 549. 549. Let's see where the next one is. I'm going to eyeball this one again. I'm going to say, maybe about there. Whoop, I gotta make this active, otherwise it's not going to read it. So yeah, somewhere maybe about there. So 1214. Let's take some data here. 1214. Okay. Look at the next one. This one's a little bit harder. I'm gonna, I don't know, maybe right in the middle here. I'm sort of weighting it a little bit. I don't know, maybe about there. This is eyeballing, so let's see, 1906. Let's see. So 1906. Just get all these things. So 2612. Oh, 26. Come on. 2612. This one, I don't know. Somewhere around there. 3245. 3245. Oh, 3245. This one, oh, I don't know. Maybe around there. 3946. 3946. And there's one left. Let's go right about here. Oh, I forgot to do this. So, right about there. How about 4625? So 4625. Okay, so now let's look at the differences. So that is number of sols between 1214 and 549.
Well, those look about yearly.
549. Yeah. 665.
Right.
Is that difference?
I think there's 668 sols in a Martian year.
Oh, okay. Well, 1906 minus 1214, 692. Now this is just eyeballing, right? I mean, I'm not doing anything extremely precise or accurate or anything here. Let's see, 2612 minus 1906. That's 706. See, 3245 minus 2612. That's 633. Yeah, these numbers are sort of all over the place, but you know, that's how it goes when you're eyeballing. 3946 minus 3245. 701. It's kind of they're pretty consistent though, not too bad. 4625 minus 3946 is 679. Okay, so let's just get an average here. I should have done this in a spreadsheet, you know? That would have been so much easier. Oh well. 665 plus 692 plus 706 plus 633 plus 701 plus 679. And then I'm going to divide that by 6 in order to get the average. So that's 679, and I'll give it a decimal place, 679.3. Okay, so my theory is, and I totally agree with you, Tom, that I think that is about a Martian year. So let's we go and find out. Where is my? Oh, here it is. Let's see. Let's go. Martian. Whoop! I think I saw it there. Oh, Martian year. 687 days. Do we have anything a little more precise than that? Can we get one decimal place?
Well, I think the 687 is Earth days.
Oh, okay. Yeah, you're right. You're right. So,
and it's not that much of a difference, but I did find somewhere that said it was 668 sols, 668 Martian days in a Martian year.
Let's see. Let's do Martian days in a Martian year. Let's see. I think this Martian year. Let's see. The length of time for Mars to complete one orbit around the Sun is its sidereal year, which is, okay, here it is, 668.6 sols. 668, and just from our really crude eyeballing, we got 679.3. So wow, that's amazingly close. That's amazingly close. But so yeah, kind of interesting that it seems like on a yearly cycle, we get these opacities that sort of, you know, go up and down like that. So yeah, I'm not sure. Maybe that's just a seasonal thing because, you know, I mean, if you're looking, oh yeah, I'm not exactly sure. I'm not exactly sure what exactly would explain that. You know, it could be a seasonal thing because of the axial tilt, looking through more. Well, no, you're not. Well, the solar angle is going to change. Does solar angle affect opacity? I don't know. I'm not exactly sure. Not precisely sure. I just, you know, I think it's kind of interesting just to look at this and think about it. We're not really here to do any serious kind of analysis, but it's kind of interesting to think about a little bit. I think I've got one for 880 also. As you can see, so let's go back to the planetary data system. Is it this one? Yeah, see, so they have tables for 440 nanometers and also 880. So, you know, very short wavelength, you know, on one end of the visible scale, and then 880 is actually on the other side of the visible scale. So, you know, they're measuring this opacity at two different wavelengths. So that's kind of interesting. And it sort of looks like they did that for both the Opportunity spacecraft and Spirit. So that's pretty cool. I've already grabbed all this data because I was looking at it before because, you know, I can't help myself. So here's the 880 data, and actually I'm going to get rid of stuff at the beginning. We can look at the 880 the same way, and it's probably going to look about the same, I would think. Yeah, more or less the same. We can actually plot both of those if we want. Let's do it like this. We'll just make 440 black and 880 red, just to distinguish them. And we'll do it on the same plot here. So let's see. Bam. Yeah, see, they look more or less the same. More or less. Now we can sort of zoom in a little bit, right? We can look from sols 1000 to 2000, say. So, you know, just look from here to here. Instead of the whole thing, let's just look in that smaller region. Whoop, I don't know why that did that. There we go. Yeah, we can look at them both. Let's see. 1000 to 2000 along the x-axis. Whoop. I don't know what that did. Line color 8. There we go. So there's a little bit more detail there. But you can see that at both wavelengths, at least both wavelengths track pretty closely, right? There's a little bit of differences in opacity here. But, and here, yeah, you know, there are small differences, but yeah, for the most part, of course. The opacity, yeah, the opacity more or less stays exactly the same. There's, you know, maybe a little bumps here where, you know, they don't exactly track, but yeah, these things are tracking pretty well. And yeah, this has got to be like some kind of dust storm or something, but it's kind of neat, right? Because even within the storm, you can sort of see where, you know, the opacity was higher and then lower. Let's sort of spread that out a little bit too. Let's go from 1200 to 1300. So we just sort of get that set. I don't know why you keep doing that. So 1200 to 1300. Yeah, kind of interesting how the opacity sort of went up, and then dropped, and then went up again, and yeah, very, very dynamic system as usual. Kind of interesting.
Kind of interesting.
Yeah. Just how thick the atmosphere changes over the course of time. Kind of neat. Kind of neat. Now let's see. Can we? Let's look at opportunity with one color and spirit with another color, and we'll do sort of their entire lifetimes here. Actually, let's make sure. I think I've got this all worked out. Oh, I don't. Okay, let me get rid of these here, and I'm going to do the same for 880. I forgot to get rid of the little headers there. Okay, so let's look at spirit and opportunity more or less over the same time period, right? I think spirit landed a couple of weeks before opportunity. So, you know, the timing isn't exactly right, but let's look anyway. Let's see, 40, 4 and 7 with lines, line width 1, line color 7. See what that looks like. Oh, okay. So yeah, this thing keeps doing that. So the red line here is the measurements of the Martian opacity from spirit, that is the red line, and the black line is the opacity from the Opportunity rover. You can sort of see that, yeah, there's a little bit of an overlap for sure. It sort of looks like, you know, there might be a little bit of a time lag here too. So yeah, you know, that's completely expected. Interesting to point out, right, that the Opportunity rover was on one side of the planet, and the Spirit rover was on completely the opposite side. So, you know, these two rovers are looking, you know, at two different Martian atmospheres, basically. But it looks like there is a lot of coincidental events, right? I mean, this is the one, of course, you know, that pops out. It sort of looks like both of the rovers experienced that pretty much, you know, at the same time and with sort of the same intensity, right? I mean, some got blocked out pretty well, I would say. But there are some smaller events here too, right? That also seem to be coincidental, right? This one here from Spirit, the opacity went really, really high, while at the Opportunity rover, the opacity did go high, but definitely not as much. Seems sort of the same here, right? There's a bump with Opportunity and a bump with Spirit the same way here and here too. So kind of interesting that events like the opacity of the atmosphere on one side of the planet sometimes do coincide with events that are completely on the other side. So that's kind of interesting. So the other thing that I did, I was kind of interested in, and I'm going to go back to, this keeps doing that. I'm going to go back to this one. So what I was kind of interested in looking at is seeing, okay, well, how many of these data points have like an opacity of exactly 1, right? And how many data points have an opacity of 3 or 4 or 5? So best way to do that is to create a histogram of this. And I was trying to figure out a way to best describe how to do this. And I guess if you sort of think of it as, and maybe I'll come back to me just for a minute here, because yeah, we should definitely look at this and then we can get out of here. I'm going to stop sharing for a second. All right, and I'm going to check my chat really quick because there's always interesting things going on in the chat. All right, cool. So to make a histogram of like a set of numbers, say that you have like a set of numbers, say that you have 20 of them, and those 20 numbers range between 1 and 5, right? So some of the numbers are number 1, some of them are 5, some of them are 2, just all over the place, sort of random, right? Well, what I can do was I can go through each one of those and, grab the number, say, okay, it's a number 1. I'm going to put that in the number 1 bin, right? Grab the next one, oh, it's a number 1. I'm going to put that in the number 1 bin. So now I have 2 number 1s, right? I grab the next one, it's a 3, say. I put that in the 3 bin. Next one, I grab a 5, put that in the 5 bin. The next one I grab is another 3, put that in the 3 bin. So now I have 2 1s, 0 2s, 2 3s, 0 4s, and 1 5. Does that make sense? I'm just sort of building, I'm counting the number of 1s and the number of 2s and the number of 3s and the number of 4s. Well, I can do exactly the same thing with this opacity data, right? We can look at these numbers, opacity 440, right? So this column here, right? And I can say, okay, how many 0.906s do I have? And how many 1.016s do I have? And how many 0.970s do I have, right? And I can add those all up, and then I can look at the data that way instead. So I wrote a little program to do that, of course, a little Perl script again. So I just create an array that is set to 0 right at the beginning. And then I grab the opacity value, right? And now that's a fraction. So it's sort of hard to do what I'm doing with fractions. So I take that number and I multiply it by 100. And then I put that number into the bin, right? And then I just add them all up. And then at the end, I just display it, right? I just show how many of these and how many of those and how many of those and how many of these I've got. And that is the histogram. So let's take a look at this. Did I can run it again here. Opacity. Can I run it in here? Probably not. Let me get out of this. And we'll call it 440. And we'll call it, oh, what's a good output file name? I don't know. We want it to be opportunity opacity 440. How about like that? Doesn't really matter what it's called. So then what we get is this kind of thing.
Uncle Bill is late.
Uncle Bill is late. So here we go. So there were 0 zeros, 0, 0.01, so da. We don't really get any kind of counts until we have an opacity value of 0.35. And there's 3 of those. There were 2 at 0.36, and then it just goes on and on and on, right? So then I can plot this, right, and see what that looks like. And if we do that, which I will do right now, up 440, 1 and 2, with lines, line with line color black. We get, okay, well that's doing the whole scale. Let's just look at the because I think we didn't really see an opacity higher than about 4.5. So let's go from like 0 to 5. What that looks like. Oh, there we go. Okay, let me make this big again. Like that. So now, how to read this is along the x-axis is the opacity, and the y-axis is just the number of times that opacity pops up. And so as you can see, there's a peak here with an opacity, and looking down here, right, I'm seeing somewhere around like 0.47 seems to be the most common one. It had something like, what, 232 values, have an opacity of like 0.47 or so. So that is the most common one, but there is quite a distribution here, right? Quite a few that go from, well, I think the lowest one that we saw was, what, around 0.35 or so, up to 1. And then there's a fall off, but then there's this long tail, right? And way out here is that highest value way out there, and there's probably just one of those. So this is just another way of sort of looking at a distribution of values, of numbers, and seeing you know what we're working with here. And it's sort of easier, you know, to pick out the most common one, which obviously is that one there. But it's kind of an interesting structure too. Lots and lots of wiggles. Have to probably think a little bit about why, you know, this opacity here is more common than this opacity? Is there, some kind of mechanism for why that is? Is it just, random luck? I don't know. Let's look. This was opportunities. Let's look at spirit exactly the same way, and we can overplot those. So let's do spirit. I think is like that. SP 40. Yeah, there we go. Let's now, of course, spirit didn't last as long as opportunity. It petered out in 2009, 2011. I forget exactly. So we don't have as much data, but we can look at it exactly the same way. 440 using columns 1 and 2 with lines. Line with 1. Line color, let's make that red. So the black one's going to be opportunity and the red one's going to be spirit. Oh. So the opacity of the atmosphere around spirit at times was much lower than that of opportunity. Kind of neat. Again, you have to think about what does that mean, right? What are the circumstances? Is this just random, or is there some kind of something operating here to to make these things look pretty different, right? Yeah, each of them has this big spike followed by sort of a lower wide thing. Here's a big spike and then this wide thing. But yeah, those shapes are pretty different. So what does it all mean? Oh, I don't have a clue. Don't have a clue. I'm not even going to try. But it is interesting, and it is definitely telling us probably, lots and lots of things about the atmosphere of Mars. Just by looking at how opaque the atmosphere is, you can find out all kinds of things about the atmosphere itself. So pretty neat. Probably there's lots of other interesting relationships to see here, right? I mean, I've just looked at 2 columns, right? That's all. And there are several, right? Solar distance, that's kind of interesting. Let's just look at that really quick. So this is the distance of Mars to the Sun in astronomical units. Let's just quickly look at that, and then we'll get out of here. Opacity 440. So it's column 1, 2, 3, 3 and 7. Let's just look at that really quick. I haven't looked at that yet, so I might as well do 3 and 7. Lines, line width 1, line color 8. Well, let's use points instead of lines, because then we won't connect. That's probably confusing things a little bit. Type 7, point size, make it kind of small. I don't know if I can interpret anything from that or not. Here's Are we looking at the right thing? Whoop. It was column 7, right? 1, 2, 3, 4, 5, 6, 7. 3 and 7. Wondering if column... I'm just a little confused as to why all of these are down here, because this should be opacity down here. Let's look at this again really quick. Let's go back to that. Okay, there's some funny things way down here for some reason. Well, that's just 1 to 1,000. What did I do? Oh, I know what it is. I have to separate these by commas. Set data file separator. It was separating these by spaces. That's not going to work. Data file separator, comma. Okay, now this will make a little bit more sense. I hope. Yeah, I don't know how really to interpret that. This is the solar distance, right? So we're sort of looking at the orbit of Mars here. And then this is the opacity of the atmosphere. So most of the time, as Mars orbited the sun, right, the opacity really didn't change much. There's an interesting little slope here, right? When it's closest to the sun, it's got an opacity around 1. When it's furthest away, right, that's around 0.5. That's kind of neat. And then there were these, I guess you'd call them instances, where the opacity just went completely wild. Yeah, kind of an interesting plot. And again, you know, I mean, it's something that you sort of have to think about a little bit. I'm not even going to try to interpret this very much, but it's kind of neat. I'm sort of inclined to look at these with lines, although I know it's going to look pretty messy. Let's look anyway. Line with, and then we'll get out of here. Saying that. Yeah, that's pretty messy. Pretty messy. So, yeah, don't really know how to interpret that. It's kind of interesting, though. All right, well, we'll have to think about that a little bit. It's just kind of neat, you know, to have access to this data, and you'll be able to look at things, you know, from the comfort of our own porch. So I think it's very, very cool. All right, you guys, I'm going to get out of here for now. Mars is a very, very amazing place for sure. We have lots and lots and lots to learn. So, all right, let's get out of here for now. So take care, everybody. Have a great evening, a great day. And just as a reminder, starting November 1st, UT, and going through the 5th or 6th, I forget exactly, UT, this live stream will not be taking place. I'm going to I'm going to sort of an interesting conference, not really, you know, going there to be an attendee. I'm actually going there to play music, part of the entertainment. But it's a pretty interesting conference, I guess. I posted a link to it over on the Discord server, so take a look over there. And yeah, it's, you know, it's a great opportunity to really, really, really try to be, you know, open-minded and curious and skeptical. And those are sort of the three pillars that science leans on. So yeah, I definitely get to practice that a little bit. Don't know what to expect, but open-mindedness is the key there. So, all right, you guys, I will see you next time, which for me at least will be a little less than 23 hours from now. So come join us again if you can. Feel free to come in anytime. Check in every single day. You can check in every other day, every week, every month, whatever you want. We are a casual group here. So, all right, you guys, take care, and I will see you on the spin. See you later.